So question 7 represents a review of some important topics that we've covered primarily last semester in terms of equations of lines, linear equations. The first equation says write the equation of a line with a slope of negative 1/2 and a y-intercept of 3. Well, if we recall this equation, y equals mx plus b is a line written in slope-intercept form. There are two variables here, right? Our variables are y, that's one of the variables, and our other variable is x. And basically, once I have identified a particular line, when I feed it an x, this expression on the right-hand side will tell me what the corresponding y value is. Now, in addition to having these two variables, right, x and y, x will change, and as x changes, it gives us new y's. There are these two things called parameters, right? And our two parameters here are the slope and the y-intercept. And actually, it probably would be smart if I color-coded this with different colors here. So the slope is this value represented by m, and it tells me how this is growing over time. So for this particular line, every single time x increases by 1, this output y value will go down by 1/2. The other thing that we have here is a parameter is our starting point, or in terms of a sequence, our 0th term. And this one's starting at -3, and then it's going down from there. So because both of the parameters are given to us, we know both m, the slope, and b, the y-intercept, we can write this equation down, right? This equation is y equals -1/2 x plus 3. So when x is 0, we are starting at 3, and then every single time x increases by 1, the output goes down by 1/2. It has this slope of -1/2. All right, the next one says what's the equation of a line that passes through 3/7, or with a slope of 3/7, and it passes through this point. So in this particular problem, we don't have both of our parameters. If I was to write down again this y equals mx plus b, I can see that we were provided with the slope. We were provided with 3/7, but we weren't given our y-intercept b. We don't know that particular parameter. Fortunately, we do know a point that made the equation true, and we can use this point to figure out this missing parameter. And to do that, we're just going to take the x and the y value given from the point, plug them into this equation along with the slope, and you'll see our only variable that's left to solve for there is our parameter b. So let's go ahead and plug those in. So y is 8. My slope is 3/7. The x value is 7. And then here's my parameter b that I'm trying to solve for. If I simplify this, 3/7 times 7, you can think of it as 21/7, or you can see the giant 1 there, right? If I have 3 times 7 over 7 times 1, this 7 over 7 forms the number 1. So I'm left with just 3. So this becomes 8 plus 3, 8 equals 3 plus b. And if I take away b from both sides, we get that b is 5. So now we know both parameters, right? Now we know our y-intercept, one of our parameters, and we already had this other parameter, our slope. So now we can write the equation of this line. This equation of this line is y equals 3/7 x, and then plus this 5, this parameter that we found. So that is b, and you can see there we were given a slope and a point, and we use that slope and the point we were given to find our missing parameter b. Now on part C, we're given neither parameter. We don't know the slope and we don't know the y-intercept. What we're given here are two different points. Now, fortunately, with 2 points and knowing that it is indeed a line, we can figure out our slope, and that's what we're going to do. Our slope, if you'll recall, is how much y changes divided by how much x changes. So we're looking at the difference in our y values. So I'm going to look at Here's our y values, and this will be in my numerator. And then these are x values, and these are going to be down in the denominator. And for each of these, because it's a difference, we're looking at a subtraction problem. And I'm just going to go ahead and write these in the order that I see them. I'm going to take the 2, and I'm going to subtract a -4. So you can see it's a subtraction problem, but it's 2 minus -4. And then down in my denominator, I have 1 minus 4. So if I clean this up a bit, 2 minus -4 gives me a +6 in the numerator, and 1 minus 4 gives me a -3 in my denominator. That means I end up with a slope of -2. So my slope is -2, which is great because this is one of the 2 parameters that I need to write the equation of this line. The other parameter I need is the y-intercept, and I'm just going to do what I did in part B. So if you look at where we're at now, part C is collapsed to part B, so we have a chance to practice that again. And it doesn't really matter which one of our points we pick. I could pick either one, but I'm going to pick this first point. You can see it has an x and it has a y. And we're going to plug everything we know into this equation, y equals mx plus b. We're going to plug in the y from this particular point, 2. We're going to plug in our parameter, our parameter of slope, which is -2. We're also going to plug in our x value of 1, and then write the plus b. So now you can see this equation will allow us to figure out what our parameter b is. It becomes 2 equals -2 plus b, and if I add 2 to both sides, I can see that my y-intercept is 4. So now I know both parameters. I know slope and I know y-intercept, so I can write the equation of this line. The equation of this line is y equals -2x and plus the number 4. So this is the equation of the line that will go through the point 1, 2, and for -4. And I can verify that by plugging in the x and verifying that it gives me the correct y for both of those points. And it does. However, I encourage you to plug those in. If I was wrong and you pointed that out to me, that would be fabulous, but I'm pretty sure I'm correct. But it's still always worth looking. And it's not very difficult. You just grab a calculator. All right, final question. This one asks us to review the relationship between parallel and perpendicular lines. We know anytime we have lines that are parallel to each other, they have identical slopes. And if lines are perpendicular, there's this relationship that happens when I rotate the coordinate plane through 90 degrees. Rise and run switch places. And if something had a negative slope, it becomes positive. If it's a positive, it becomes negative. So we kind of summarize that idea by saying that if 2 lines are perpendicular to each other, they're opposite in sign, and because of the rise and run switch places, they're reciprocals of each other. So if I look at this line has a slope that is -3/2. Well, I'm looking for the slope of a line that's perpendicular to that. So the slope of a line that's perpendicular to that line would have a slope that's +2/3. And this is the slope that we're dealing with. So you can see this is one of my parameters, and I need to use that parameter with this point. And again, there's an x and a y there to figure out my y-intercept. So again, I write y equals mx plus b. I can see that my y value from my point is 4. I can see that the slope is 2/3. I can see that the x value is 3, and I'm trying to figure out this value b. And again, if I clean this up a little bit on the right hand side, 2/3 times 3 is 6/3, or you can see the giant one there, but anyways, this simplifies to just 4 equals 2 plus b. And if I take away 2 from both sides, I get that 2 is what b is. So I can see now I have both parameters. I know the slope and the y-intercept, so I can write the equation of the line. It is y equals 2/3 times x, and then plus, not b, I just found it. B is 2. So y equals 2/3 x, and then plus 2. And it's fun if you've got a moment to pop open GeoGebra and graph both of these, and if you measure the angle between them, you're going to see that it is exactly 90 degrees. These lines really are legitimately perpendicular to each other. One's crossing the y-axis at 8, and the other one's crossing the y-axis down at 2.